We're carrying on with the halogens. So you've been given bromine, chlorine, iodine, and you've been given potassium bromide, potassium chloride, potassium iodide. You need to describe 2 experiments in order to show the reactivity of bromine, chlorine, iodine. So look, fluorine, chlorine, bromine, iodine. That's too dangerous in the lab, so we tend to use chlorine, bromine, and iodine. Reactivity decreases as you go down. So we've got to show that these are in that order. So you've got let's try it like this and see what it looks like. So this one is potassium iodide. Potassium iodide. This is potassium chloride. Potassium chloride, and finally this is potassium bromide. Potassium bromide. Right. First of all, what we need to do is add bromine solution. So remember these are all aqueous. Add bromine solution to potassium chloride, and there will be no change will occur. Right. So then we know that chlorine is more reactive than bromine. So we know chlorine is more reactive than bromine, but we don't know where the other one is. So the second test, we're going to add iodine, aqueous iodine. They've already said it's aqueous, so solution. We're going to add that to potassium bromide, and there should be no change. So what that tells us is iodine is less reactive than bromine, or bromine is more reactive than iodine. So that goes in that order. It's more like a puzzle, really. So this shows that chlorine is more reactive than bromine, and let me push this up, right, and chlorine, bromine, and bromine is more reactive than iodine. So you end up with chlorine most reactive, chlorine, bromine, and iodine least reactive. And just leave it like that. That's it. Okay. This question is about halides. At room temperature, bromine is Chlorine, chlorine, bromine, iodine. Gas, gas, liquid, solid. So bromine is a liquid. So it's a liquid and it's a liquid. It's not that and it's not that. We know that. So now the question is, what color is it? It's red brown. So remember, vapor, vapor, and it was you greedy red brown fox wearing orange high vis jacket jumping over a grey fence chasing a purple chicken. So it's a liquid red brown. That's the one. Sodium reacts with bromine to form sodium bromide. Right, sodium plus. Remember, bromine is what? Diatomic. That means it runs around in pairs. So how do we remember the diatomic molecules? We say no. And then you've got fluorine, chlorine, bromine, and iodine. So now these are all, they run around in pairs in the natural world. Those are the ones we're interested in, I think. That's it. Right, so you've got bromine, so you've got sodium. Right, yeah, that's supposed to be like that. You've got sodium bromide. You've got 2 bromine atoms, so you need a 2 there. So the bromine's alright, but now you've got 2 sodium atoms, so we need to stick a 2 there. So let's move on. Right, we are looking at student carries out some experiments, investigate the reaction. Right, why did she not do some of these experiments? So if you look at this one, and this one, it's like the previous question, or previous question that we're looking at. It's a, so have you noticed that's bromide and you don't react it with bromine? This is chloride, you don't react it with chlorine, and same way this is iodide, you don't react it with iodine. So that's why we didn't do this, or that one. Okay, so all you write it down, a halogen cannot displace itself. Sorry about that. But okay. The table shows there was no reaction in 3 of the experiments. Right. That's that one, that one, and that one. Right. The reason is because you've got chlorine, bromine, and iodine. This is the strongest or the most reactive. Right. Now what? Chlorine, bromine, iodine. Most reactive, least reactive. So what's going to happen is iodine cannot displace bromine or chlorine. So iodine cannot react with either chlorine or bromine. I'm not saying that the right way. So iodine cannot displace chlorine, and iodine cannot displace bromine. And it will not react with itself. So there's no reactions taking place on any of these 3 really. Even if you tried one here, it wouldn't do it. And that one, chlorine cannot displace its own, and bromine, where are we? Bromine cannot displace chlorine, so that won't happen. So it's the same answer. So A halogen cannot displace or cannot, cannot, actually the word displace a more reactive halogen. Okay, so that's what they're saying. Anyway, let's move on. You've got bromine plus potassium iodide, so you've got chlorine, bromine, iodine. We said fluorine is too reactive, we don't even include it in that list. Right, this is the most reactive, and I look at it as it's the strongest. So if iodine wants to displace that, it says go away, I'm stronger than you. Right, now will bromine displace? Yes, it will. So the name of one of the substances is incorrect. So that should be potassium bromide. You've got the ide. Write the correct answer. So it's potassium bromide. There you go. Right, we don't need a capital B there, really. So let's make it lowercase, bromide. Right, a reaction occurs when student adds chlorine solution to potassium iodide. So chlorine to potassium iodide gives iodine and potassium chloride. Now we need to balance them up. We've got two chlorines, we've only got one chlorine, we have to stick a 2. We have to stick a 2 here. Right, we've got two potassiums, so we need to stick a 2 here. Now we've got two potassiums and two iodines. There you go. Right, what is a redox reaction? So redox. I think this comes from reduction, and that comes from oxidation. So it becomes a redox reaction. So this is when both reduction and they've highlighted this and oxidation occur in the same reaction. Right, we've done an ionic equation. So the reason what they're saying is it's ionic because is you've got I minus. I minus means that it's an iodine. It's an iodine atom that's gained an electron to become an ion. That's why you've got the minus there. It's got an extra electron. So what happens is explain which species oxidize. Right, okay. Let's try to get this right. Right. Oil rig. Learn it as an oil rig cap. That is short for anode, and that is short for cathode. When I see this, I start and I panic because the positive anode is the positive electrode is an anode. The negative is the cathode. That's how I remember it. An oil rig. So oxidation is the loss of electrons. and reduction is the gain of electrons. There you go. Oil rig cap. Right, so we now need to, from that, so all that information has been given, right? So remember it as an oil rig cat. Oxidation occurs at the anode, reduction occurs at the cathode. And oil stands for oxidation, and it's the loss of electrons. Reduction is the gain of electrons. So now, if you look, bromine has gained an electron, so it's been reduced. And iodide, the iodide ion has lost an electron to become a what? To become an iodide. Well, it's been oxidized and to be oxidized to become an iodine atom. So what we're going to have to do is, oh, I could leave this list right, just write in that here nicely. So the iodide species has, as it's saying, explain, has lost electrons. There you go. Right. What is the name given to group 7? We said that's halogens. Symbol of two isotopes. So what did we say an isotope was? Isotope. These are atoms of the same element that have the same number of protons but different number of neutrons. Important to learn that comes up a lot. Oh, there you go. So that would go there. That's probably the best definition and clearest definition. Keep to that. You can talk about what do you call it? Atomic numbers and relative atomic masses, and just forget that. Right. So number of protons is 35. Number of protons is 35. Because they're both 35, that is what makes it a bromine atom. It's not the top number. Right, number of neutrons is 79, take away 35, which is 44. And this is 81, take away 35 equals 46. And it just happens to be the case that, look, the number of protons, the number of protons is the same as the number of electrons. The number of protons is the same as the number of electrons. But this number here does not stand for electrons, it stands for the number of protons. Just remember that. It's a common problem. Right, okay. Let's have a look. Right, okay, so describe what you observed with orange bromine water. It's added separately to ethane and ethene. Right, okay. So what we need to do is that is an alkane. That is an alkene. Right, observation with ethane is right. There would be no reaction. No reaction. So we would expect no color change. Right. The key thing is its absence with UV light. How should I do this? Right, okay. What would happen? It would go from orange to colorless. Right, well, I'm gonna just show you this. Right, when you've got an alkene, so remember we said alkene has got two E's, so it's got a carbon to carbon, a double bond, right? So you've got each carbon has got 4 bonds. So ethene looks like this. Now, one of the tests to test for a double bond, an alkene, a double bond, or something called unsaturated compounds, is to add orange bromine water, and it turns colorless. That's that. Now, if you want to react, just say let's just use, this is called methane. It's an alkane. If you want to react an alkane to bromine, I'm going to separate it like this, Br-Br. You have to have UV light. Right, and then what happens? Let me try to get this right. The hydrogen is substituted with a bromine, and you get something called a substitution reaction. That's what happens. I just wanted to show you here, that's what happens. Because there's no UV light here, there's an absence of it. Absence means no. خلاص, nothing. Nishta, nein, no, never, and whatever. Right, let's move on before I start talking in 6,000 languages. Right, okay. Whoa. 23 minutes. Let's see. Can we squeeze this in? Yes, we can. Let's try to squeeze this one in this video. Right, you've got 3 aqueous solutions. Sodium chloride, sodium bromide, and sodium... No, stop it. Just making stuff up. Silver nitrate. You've got sodium iodide. And you have sodium chloride. They are all aqueous. That means that they are in water. Yeah. Right. The solutions are mixed together as shown in the table. So you mix solution X, and right, we don't know which one's X, we don't know which is Y, and we don't know which is Z. Okay, so If you mix solution X and Y, you end up with a yellow precipitate. Right. Fluorine is too reactive, so we use chlorine, bromine, and iodine. And when you mix this with silver nitrate, you end up with a white ice cream with a hint of lemon. So I remember that as a white precipitate, as a cream precipitate, and as a yellow precipitate. We've got a yellow precipitate, so we know it's going to be iodide. So if I mix them two, I get iodide. If I mix X and Z, if I mix X and Z, I get no reaction. So X, if I mix them two, they will stay the same. So it will be X and Z. So we know one of them is X and we know one of them is Z. We don't know which way around yet, but we do know X, if that is X and Z, and we definitely know that this is Y now. Right, so if we add solution Y to Z, we get a white precipitate. So if we add white to Z, so I now know, because this will give me a white precipitate, so it has to be that. So I now know that that is Z. Have we got any nice colors? Right, oh, they're all done actually. So I know that this is Z, I know that that is Y, and we know that is X. Okay. Explain how the results show that Y is aqueous silver nitrate. Right, because a precipitate, yeah, because a precipitate was formed each time it was reacted. Right, explain how the results can be used to identify both X and Y. So we've said that Z is sodium chloride. We said here, up here, Z is sodium chloride because you got a yellow precipitate. No, you got a white precipitate. We got a white precipitate. I'm using not PowerPoint. That is short for precipitate. Now, what else is there? Okay, that's it. So if Z is sodium chloride, X is sodium, what do they call it, iodide, because you ended up with a yellow precipitate. Okay. Aqueous chlorine is added to separate aqueous solution from sodium chloride and sodium iodide. Explain how the observation can be used to distinguish between sodium chloride and sodium iodide. Right. It's again, right, let's write it in this form. Sodium chloride. Let's then write down sodium bromide, and then let's do sodium iodide. So we know that they're in this sort of between sodium chloride and sodium iodide. Right, what you would do is, if you reacted sodium chloride with if you okay, if you added, let's get this right. How can you decide? Right, sodium chloride, sodium iodide. So if you reacted sodium iodide with sodium chloride, you would get no reaction because chloride is chlorine is stronger than iodine in terms of reactivity. And if you added sodium chloride, no, right, I've misread the question. That's really bad. Let's try this again. Right, you're adding chlorine solution. So if I add chlorine solution to this, it would be no reaction because a halogen cannot displace itself. Right, and now if I added chlorine, to sodium bromide, it would kick out bromine, it would displace bromine, so you'd end up with sodium chloride and bromine. And we said bromine water is brown, is a brown solution or brown color. So what we can do is say if sodium chloride, if added to sodium chloride, no change. Yeah, there's no reaction. If you add it to sodium bromide, the solution would turn brown because of bromine water. Solution would go brown because what do you call it? It is brown. What is brown? Bromine water. Bromine depends on how concentrated it is, but they've said bromine water is brown, and we're used to add orange bromine water, so brown, orange, light brown, they'd accept that. Right, we're gonna bubble through final color type of reactions. Okay, so we'll come to that in the next video.